Welcome to second lecture of the third chapter of our comprehensive course on machine learning, data science and artificial intelligence. Now here we want to talk about tuples. However, before that, I just want to introduce one concept about the list that I want that you should remember. That list can be heterogeneous because all the examples which we had taken in previous lecture, say here only numbers are there. Then here, for example, then all elements are string. So that should not give you false idea that for list all elements must be of same time. That is, all must be of all are integers or all are strings, etc. All elements can be of different types. For example, if I take a list like this, first three elements are integer, then I write my name, that is a string, then I write my firm's name, that is also a string, then I can even put another list inside the bigger list. This is called nested list. Okay, and then this is a list of integers, and then I can put another list like this, which is inside, which is a list of string. Okay, so still you will see that it will be perfectly printed. Okay, not only that, in such case you have to understand how you will access individual elements, because say these are very easy. These will be L0, L1, 2, 3, 4. So we start index from 0, but the question is I want to access only these 6 elements, 6 inside this nested list. So what should I do? Then I should first take the index of entire that list, that is this 5, 6, 7. Okay, so what is this index? 0, 1, 2, 3, 4 and 5. So I will write 5. But if I just access that, then let us see what happens. Whole list will be printed. Okay, so I don't want that. I want that only 6 out of that will be printed. So in the inner list I again start counting from 0. So 0, 1. So that means I will put another square bracket and write 1 and then I control enter. Then that 6 will be accessed. Same thing you can make a practice about these also. That is also a nested list. And you can do any depth of nesting. That means inside nested list, a comma and another list. Then inside that list, still another list, and so on. There is no limit to it. Now you can understand why this is such a powerful data structure. Okay. So yes, this I want to keep so that when you get the Jupyter notebook, you will remember that how to access individual elements from a nested list. Okay, fine. Now let us start about tuples. Now here, tuples are also ordered collections, just like lists. So again, for them also, their natural order, normal order by which they were indexed. And once you access them by their index, normally throughout their life cycle, you will keep on accessing by same index number. That means even after making some changes, you will still access by same order. Okay. But one important difference between list and tuple is this, that tuples are immutable. So immutable means for list we have said that they are mutable. So mutable means something this kind of situation, that if I want to, currently this list has 0th element as 1, but if I want to assign a new value, then I can easily assign a new value. And not only that, I can even change the value of, data type of that. I have made it str, and now if I print L, then you can see originally it was integer, and now it has become a string. So that is why we say that lists are mutable. Mutable means that their individual elements can be assigned a new value. Okay, but tuples are immutable. If you try to do same thing with tuple, then it will raise an error. So once a tuple is created, you cannot change its element. This is the example of tuple. Okay. For example, tuples are written always in that kind of parenthesis. And of course, here also you should remember that heterogeneity is allowed. So one element is integer, another element is integer, but this element is a string. Then this is another tuple which is nested inside the first tuple. So any depth of nesting, that is also allowed. Okay. So tuples are shown by ordinary parentheses. Let us show what are some key methods for the tuple. But again, there is no need to remember these or any other diagram for that. Okay, I just told you how to remember this kind of situation. For example, first define a tuple t equals in a parenthesis 1, 2, 3, 4, and then in next line type t, put dot and press tab character, and you can see that these methods are available for this count and index. So that means for tuple only 2 methods are available, not many methods. Okay, so what count gives? Count will give the number of occurrences of one particular thing, which one particular element which you specify in the bracket, and index will give the index of the element where that element is located inside the tuple. And for that, after index in the parenthesis, you have to specify the value of that element. However, there are some other methods also, that is len, sum, then sorted, min. Okay, so here some such methods are shown. Okay, now let us try this. Creating a tuple. So we first create one such tuple, 1, 2, 3, 4. Okay, and 1, 2, 3, 4. And here you can see uniqueness is also not required. Same thing is about list also. 2 appears 2 times, so that is perfectly all right. There is no such requirement that element can occur only once. That means all elements must be unique. List does not have any requirement. Tuple also does not have any such requirement. Now we are going to access the first element. Then you are trying to access that element by using ordinary index notation. And if you want to create another tuple from this tuple, that is called slicing the original tuple, then you can slice it like this: -3 colon. Now what does this mean? That we will see. -3 means you have to start from the right side, that we have seen earlier also, and the minus sign means that, and 3 says how many elements you have to walk. So you have to walk 3 elements, okay, and up to what you have to do that process, or from where you have to do that process, then start from the beginning and go to the end, but only 3 elements. You don't go to the end of that. That will extract the subtuple, you can say, just like we use the word substring from a string. So that will access the last 3 elements of this tuple. Okay, let us print this. So you can see this first element is accessed by index 0, and that was 1, and last 3 elements are accessed in this manner. So that is defined. Now you should remember just one thing, which is a common source of mistake, that tuples are shown by ordinary parentheses, but when you are indexing, when you are accessing individual elements, at that time these elements are specified by square bracket only. That is, they will be specified by square bracket for list also and for tuples also. Okay, so here you should not write that parenthesis thinking that I am accessing elements of tuple, so the symbol must be different. No, the mechanism by which individual elements are accessed, that remains the same whether you are accessing list or tuple. Okay. Now immutability. Now this is important because I have 1, 2, 3, 4. Okay, this is my tuple. Now I want that its first element to be changed to 5. In list, I showed that that was very easy. In fact, I can even change the type also. Instead of first element, which is integer, I can assign one string, and list will happily accept because list is a mutable data type. But for tuple, if I try to do that, then this will raise error. Okay, tuple object does not support item assignment. So that means you cannot assign a new value to the value which is already stored inside the tuple. So once a tuple is created, its elements cannot be changed. Okay. Now count method. So count, as I said, will count number of occurrences. So here my tuple is this. So that means 2 occur twice, 2 times. So then count method will find that 2 times. Okay. And index method is used to find the index of any particular element. For example, here this is my tuple. So the index of this element is 0, 1, and 2. 2 is the answer. So then this will give answer 2 because index is 2, and this will also give answer 2 because the number 2 appears 2 times in my tuple. Okay, so you can see both answers are 2. If you try to find other functions, though this diagram has mentioned some minimum and maximum, etc., but I think that such methods do not exist. Let me try, but I think they do not exist. My tuple, because I showed you that standard method, put a dot and put a press tab, and you will see all possible methods. So my tuple dot max, if I write, assuming that it exists, then it says that there is no attribute max. Okay, so you should, I should rather change and delete that diagram. I think this is for some other data type, and by mistake tuple is written here. Okay, so I will delete. Only 2 methods for tuple. One is count, how many times an element occurs inside the tuple, and one is index, what is the index of the element inside the tuple. Okay, where the tuples are useful? Tuples are used to return multiple values from a function, because when you are returning value, you want to make sure that between the returning of the value and that value being assigned in the calling function, by mistake the values which are being returned, they do not change. That means you want immutability. Now sometimes we have seen that helper function, etc. thing. So we know that one function returns the value to other, that in that other function some operations may be done, then that function returns the value to some main function and something like that. Now if by chance any operation changes the values which are being returned, then there would be issues. Okay, so we don't use list usually for returning, we use tuples. Then unchangeable data. If you want to store something which you don't want to change later on, for example, some event you are recording that today is suppose 15th of whatever month and whatever year, and this event has occurred, then you don't want, you want to keep your record authentic and unchangeable. So at that time you can use these days of the week. Similarly, GPS coordinate of a place. Now every location on earth has a unique GPS coordinate. And that means if my office has a particular GPS coordinate, then I will never require to change it later on in my data set. Okay. Then hashable keys in the dictionary. Now what are they, that I will have to discuss when with a dictionary. But tuple can be used in the dictionary because they are immutable. Because whenever we will see these dictionaries, you will see that dictionaries are slightly mixed type of data structure. Lists are mutable. Tuples are completely unmutable. While in the dictionary, there is a pair of key and value. Here it is. This D is called key and this dog is called value. Now for dictionary, the condition is that the keys must be immutable and value can be mutable. So that means, can I use a list as a key? No, because the condition is that list key must be immutable. But can I use a tuple as a key? Then yes, I can use a tuple as a key. So we can make hashable keys for dictionaries using tuple. Okay. Now in next lecture we will do about dictionary. Thank you.